Welcome back to my channel Siddhanath Nishandar. In previous lecture, we started the jet engines. What is the difference between jet engine and gas turbine? What is meant by jet propulsion? Okay, in today's lecture, we cover the remaining part of the turbojet engine and their applications and the turbopropeller engine. Okay, there are some applications of the turbopropeller engines we further see in the detail in further slides. I shortly cover the again what is meant by jet engine. Okay, in previous lecture we discussed the what is meant by jet engine. We know that the jet engine, main purpose of the jet engine, heat energy is converted mostly into the kinetic energy when jet of exhaust gas passes from the exhaust nozzle, creating thrust. Okay, we remember some keywords. In for case of jet engine, there is the nozzle, thrust force, diffusers are the some changes as compared to the gas turbine. I have compare in last lecture also. In gas turbine, there is no need of diffuser, no need of nozzle at the exhaust. But in case of jet engine, is a product with the initial part is the diffuser and the at the outlet is the nozzle which act as the which produces thrust force for the propulsive motion. Jet propulsion engine is classified in two groups: atmospheric jet engine and the rocket engine is also called as the air breathing and the non-air breathing engine. Okay, this rocket engine, there is the again classified in solid propellant and liquid propellant. The rocket engine, the last part of this topic, we discuss him further in detail. Okay, today we focus what is my turbojet engine, turbopropeller engine, and the ramjet. In today's lecture, I cover turbojet engine and turbopropeller engine. Is air atmospheric jet is also called as the air breathing engine because it sucks the air we need for the high pressure, high temperature air for the combustion, and we sucks from the atmosphere. So such engine is called as a air breathing engine. Okay, and again revise jet propulsion, that heat energy is converted mostly into the kinetic energy with the help of the nozzle is provided at the exhaust, and the gas turbine is which produces mechanical power in the form of rotating shaft. Okay, today's lecture, previous lecture, we also discuss the gas turbine is utilized for mechanical power and the jet engine. Now the total, suppose the 100% we assume the combustible products here. In combustion chamber we produce 100% of combustible products. Out of that 100, only 20% is utilized to run the turbine. Okay, and the around 80% of the combustible products is flows over the nozzle. Okay, that 20% power developed by the turbine, that is mechanical power utilized to run the compressor. Okay, and out of 80 and remaining 80% combustible products, that high pressure, high temperature combustible products flows over the nozzle to produce thrust, to produce propulsive motion. That is the main difference between the gas turbine and the jet propulsion. It works on principle of Newton's third law of motion. Like I will show you one simple principle. It works like a balloon. Okay, we release the balloon, it produces thrust at the end, and the balloon, the reaction in that upward direction. On the same principle it works. Okay, now we see one application of the turbojet engines. See here, this shows the exploded view of the jet engine. This shows the compressor, combustion chamber, turbine, nozzle. It simply works on principle. I told that, like Newton's third law of motion. The balloon, simple example take. We produce thrust, so that reaction force will propose the in forward direction, to propose the plane in forward direction. We see here which opposes that drag force, the opposed by that plane to the air, to overcome that drag force with the help of that producing thrust force. The atmospheric cold air and the exhaust is the hot air. If you observe here the annular space also, fuel injection holes, air entry holes. I previous lecture told that it consists of the two space, annular space, okay, and the inner space. In the inner space, the combustion of the fuels takes place, and the annular space utilized for the cooling of the combustion chamber. So only 25% of the primary air is utilized to combustion, and the remaining 75% air to use to cool the CC, to cool the nozzles because of some material considerations. Okay, further this shows how it produces the, how it works, how it produces thrust force. Okay, compressor turbines are coupled to each other. They use their cross-sectional areas. They produce a thrust force. With the different applications, also the turbojet engines. Okay, how the direction thrust control on the military fighter jet engines, how they control, how it works. Okay, how axial flow compressor works as shown here. You see there how axial flow compressor works, how the directions of the thrust control, how to control on the military fighter jet engines. Here 10 to 20% of expansion of hot gases takes place in gas turbine to produce the power just sufficient to run the compressor. Remaining 80% to 90% of expansion hot gas takes place in the exhaust nozzle. I also discuss. Okay, see the further application also. Turbojets are generally used in high-speed fighters, bombers, and airlines. The source of providing energy for the forward thrust in this case is only the high-velocity jet, and hence the name turbojet. The whole propulsive motion is achieved because of the thrust force. The most suited for aircrafts traveling above 800 km per hour. Ammonia is injected, is very important, to the combustion chamber to increase the mass flow rate and hence the thrust. The different applications. In 1983, the car reached a top speed of 650.88 mph. You see here what is the speed. They also utilized for the racing cars. It is powered by the single Rolls-Royce ion jet engine source. Okay, this is sourced from an English Electric Lightning. Also, we see the next application. The Me-262 was the world's first operational jet-powered fighter aircraft. Okay, at the speed we see there is as much as 100 mph. There are some different applications of the turbojet engines. See here. Now start with the turbopropeller engine. Okay, as compared to the turbojet engine, what is the change we observe? If we see the basic constraint similar, is the compressor is there, combustion chamber is there, jet exhaust nozzle is there, but only change is that is propelled with or is adopted with some propeller. The word propeller, turbojet. Okay, most of the thrust force is created by the jet, so it is called as a turbojet. Why it is called a turbopropeller? Because the propulsive motion is get or recovered with the help of propeller, so it is called a turbopropeller. Most of the thrust force created with the help of propeller, so it is called turbopropeller. And there the most of thrust created by the jet, so it is called a turbojet, is the main difference. Okay, where we see the compressor and this propeller is coupled to the again turbine. If we see here, compressor already coupled, as well as now change is that propeller is also coupled with the compressor via turbine. Okay, now we see how it works. There is again diffuser is there. When compressor starts rotates, okay, initially we know that to run the compressor we need some starting motor. When compressor starts to rotate, it creates, it going to pressure reduces in the chamber, so the atmosphere airs enter in this chamber via diffuser, where because of the ramming effect, because of some cross sectional area, the pressure is partially increases in diffuser. Further compressor is goes in the compressor, where the pressure is increased up to 40 bar. In case of turbojet engine, it is only 4 bar. But in case of compressor here, in turbopropeller, pressure is going to rise up to now 440 bar pressure. That high pressure is then supply out the combustion chamber. Okay, now see here what is the difference now. Out of that 100% combustible products, okay, 80% power is developed by the turbine. I again repeat, 80% of the 100% of combustible products, around 80% the combustible products is flows over that turbine. Okay, in order to run the compressor and run the propeller. So it is the main difference, because the maximum thrust created by here in case of turbopropeller engine with the help of propeller, so it is called as a turbopropeller engine, and the only 20% of the combustible products flows over the nozzle to produce thrust force. So here in case of turbojet is the vice versa, only 20% power is in turbine and 80% power in thrust, and turbopropeller engine 80% in propeller. With the help of propeller we produce thrust force, and the only 20% in jet is the main difference that is between turbojet and turbopropeller engine. Also we can run the propeller with the help of IC engines. Some aircrafts are provided along with the IC engines, replaced with the gas turbine. Okay, is also is a product with the speed reduction gearbox is there. If you see here, this speed reduction gearbox is provided to control the velocities of the propeller or the RPM of the propeller. As shown here, how propeller run with the help of IC engine, with the help of turbojet engine. There's some applications: Airbus A400M turbopropeller engines, some military transport aircraft. If you see the huge applications of the turboprop engine. Also I show some how it works, how the propeller design according to modifications in the blades. Okay, there are different applications also with, along with the IC engine. I show some the world top 5 turboprop engines. See here. The maximum speed has shown, how it works. See here. The range is there, speed is there. Please subscribe my channel Siddharth Nishandar. Hopes you are enjoying these videos. Thank you.